computer and do that whole thing. It's a pain. All right. So, if you have a metal on the left, non-metal on the right, they get together using ions because there's a transfer. But if they're both on the right, they're both non-metals except for hydrogen, right? That counts too. If you have two non-metals, because their electronegativities are higher, no one wants to lose this, right? If this is our electron, if I'm N or O, I don't want to get rid of it because I want my electrons and I want yours because I want to get that full valence shell. So what they decide is they're just going to share it because they both have a high attraction or strong attraction for electrons. Okay? So now what we're going to do is take this and apply it to dot structures because this explains why when you're doing these dot structures you need to label your metal with a plus charge and your non-metal with a negative because that shows losing and gaining. But down here we're not showing charges. Okay? So we're going to practice doing dot structures and explaining how their electron configurations change from when they're individual elements to compounds, right? They want to be full valence shell, but we need to make sure we can write that down. And that's what your homework's on. All right, did everybody get that? Did you check? Why don't you check real quick, make sure everyone got that. Check the remind, check your text. Go ahead. All right, if you know you got it, then you don't have to check. Just because I put in like the directions, the instructions. I want dot structure, what type of bond, charges if they need them, electron configuration. Probably would have been better if I just, I guess, wrote the directions, took the picture with it, but. All right, so let's do one of each right now. Let's do strontium chloride. So we're going to go SrCl2. All right, we're going to do that dot structure first, then we'll do a covalent. Okay, let's do the individual dot structures first. So I have one Sr, I have two Cls. How many dots does Sr have? How many dots does Sr have? 2, but I want to make sure everyone knows why. It's because the last number in its configuration is 2. So Sr has 2 dots. They are not together. Only helium's 2 dots are together, or Li plus would be E plus 2. All right, how many dots does Cl have? 7. So both of them, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Got about 10 minutes here, so I'm going to go slow. I'm going to do these 2 examples, but I want you to really pay attention. How many bonds can Sr make? 2. Well, that works out perfectly. How many Cls are there? 2. How many bonds can Cl make? 1. So just watch before you write anything down. If we take this dot and bring it right over here, so now this dot and this dot are paired up to make a bond. By the way, I'm going to change these to X's just to make it a little bit easier for my example here. So Sr has 1 dot, Cl has 7. I'm going to put this dot right here, so just watch. Don't write anything, just watch. All I did was put these 2 together. Sr still has an X up here that has not bonded yet. Again, the X and the dot at the same time. I just do that to say, okay, here's Sr's valence electrons, and then the other ones are Cl's. So when we're doing these dot structures, it's good to write the individual, like exactly what we did, write each one by themselves. Then look at it, it's kind of like a puzzle. How can I put this together that makes sense? Well, I can't put another Cl on this Cl. Why?
Because it doesn't make sense.
Can't make it.
Well, it doesn't make sense because it's full. There's no dots by themselves, right?
Then you do another one.
So it goes on
SR. With
Right.
X, and then another one.
So there's only one place this dot and this dot can overlap, and it's right here. So this dot goes right here. So now I put the Cl on top of Sr, and that's the dot structure for
And it's okay to
SrCl2.
write it that way.
It is, yep. You can actually write the 2 Cl's anywhere you want as long as they're attached to Sr.
Okay.
So before you write, hold on, eyes up here again. This is one bond, here's another. And this is ionic. What does ionic mean? They transfer. Who loses? SR, so we have to write +2 next to SR. That shows it's losing 2. Each Cl is gaining 1. -1 here, -1 here. Go ahead, you can copy that down, and then I'll continue talking about it.
YouTube video will have a good view of you eating.
I'm not sure they can see this. I guess I'll find out. Don't talk with your mouth open. Or mouth open. What?
I can't do that.
You ever hear anyone say, anyone who's angry, shut your mouth when I'm talking, or no, shut your mouth when you're talking to me?
What?
Right.
I was thinking.
No.
Oh.
People are mad, say it wrong. Shut
That's
your mouth when
the
you're
time.
talking to me. Alright, now, this now is stable. What's the configuration of SR +2?
2, 8.
Look it up. Let's go, Renee. Get involved.
2, 8, 18, 8.
2, 8, 18, 8. Good. What's the configuration of each Cl? Anybody?
2 and 8.
2, 8, 8.
Darn it.
Label that. This is exactly what I want you to do on your homework, except you would also write it's ionic. It's ionic. Here's my configurations. There's my dot structure. Don't forget my charges. Your charges, whatever. The charges need to be there. They need to be there. So that's just one example. You're going to apply it to the other ones for homework. 3 of those on the list there are ionic, 3 are covalent. Okay. Moving on. Next, we're going to do a covalent. So let's go with, we'll keep Cl going here, PCl3. PCl3. All right, so again, we're going to do all 4 of these by themselves. Cl is the same, 1, 2, 3, 4, 5, 6, 7. So go ahead and just do those real quick. You have 3 Cl's, each with 7 dots. Who can tell us how many dots P has? 5. Fred. How many bonds can P make? 3. What about Cl? 1. So wait a second. Cl can only make 1 bond each. And how many Cl's do we have? 3. How many bonds can P make? 3. And there's 3 Cl's. So looks like this Cl can just slide in here. This Cl can slide in down here. And then this Cl can slide in over here. That's exactly how we do this dot structure. So we have P with 3 bonding spots available. And then 1 Cl goes here, 1 Cl goes underneath it, and 1 Cl goes over on this side. Except, again, I would like to make one of these dots X's, just so I'm going to make the P have the X's. It's just easier than drawing all those X's around Cl. So there's your dot structure for PCl3.
I have a question.
Yes, sir.
If so, say you have like, could it like make it not stable? As in like, say don't like you doesn't equal out to 8.
It will every time.
It will every time. Okay.
Except for the metals. If you look at SR, it doesn't have 8 dots around it. No, look at the example in our notes.
Yeah.
SR only has 4, it had 2 electrons here and then 2 here. But it does have 8 if you write its electron configuration, you just don't see it.
Okay.
The non-metals, you will always see 8 around it.
And then if something is in group 18.
It doesn't bond, so we don't worry about it.
Okay.
Okay, so the configuration for Cl, we just did it. 288, 288, 288, and then P is also 288 actually. actually, because it's sharing. So it's sharing these 6 electrons. All right, look up here for me. This P is sharing 1, and this Cl is sharing 1. So is here. So these 6 are being shared. Shared here, shared here, shared here. So P has 2, 4, 6, 8 around it. So does Cl, and so does Cl. So when you look at their original configuration, 285, 287, because they're sharing, they all get 8. No charges because it's covalent. There's no transfer, so no charges. So on the homework, you would do this, and then you would write covalent. And then you would move on and do the next one. Questions? Why do they share electrons?
She had full valence shell.
All good things. Something else. How come they don't transfer?
They both have high.
Yes, they both want them. They both have high electronegativities.
No, what if there's a both? As like,
You don't have to do this. I'm not gonna. We won't have to ever have to do dot structure.
alright, good.
Okay. How much time do I have? Couple
9
minutes. Hold on. I feel like I'm forgetting to tell you guys something. Right over the homework.
Darn me.
Oh, this one? This one's tricky. Good luck. I'm not gonna help you with it. Just good luck. Okay. Listen. Alright, we're done.